Hello, welcome to the web session Power Units with Condition Monitoring. Today we will show you a brief presentation of our new power units, which has as an accessory or integrated monitoring sensor, which is monitoring the condition of the power unit. First of all, I have to tell you that this is a display which we normally use on the exhibition. You see the power unit itself with the sensor system. And for explanation, we have here a display which we will use later to explain some short simulation. Okay, the power unit itself is based on a modular power unit system where we offer a huge range of different tank capacities, flow capacities, pressure levels, and number of circuits, hydraulic circuitries. Okay, first now we will switch into a short presentation, which is a few slides to explain the condition monitoring system we offer and its background a little bit. Okay. Okay, so now you see the subject is hydraulic power unit with condition monitoring of hydraulic oil. So here we are with the monitoring more concentrated or mainly focused on the hydraulic oil monitoring. So the next slide, please. Here you see what it is all about. Hydraulic oil is a constructive element with a variety of tasks. So one is the power transmission. It is lubricating the system. It is regulating the heat and keeps it balanced. And it is also the medium to transport the dirt and particles within the oil back or into a filter system to get it filtered and cleaned. So condition monitoring means a continuous and therefore also online condition monitoring of hydraulic oil. And you see this graphic which shows one thing is the early detection of the problem, and this is leading to a service optimization. On the other hand, we have to make maintenance more predictable. So this is a big advantage to predict the maintenance, and this is giving some effects on making things and service issues effective. So it is finally optimization of the entire maintenance process, and this leads finally, both of these things leads to a cost reduction and the increased availability of the power unit, which is the most important thing to keep the process running more or less 100% of the time. Okay, the next slide will give you just a brief overview of the which kind of things we screen. So we have different values, and you see this is a screenshot of the power unit of the screen display which we have for the exhibition. So we have 5 different things we need to screen, or we screen. First is the electric conductivity. So this means this is the material which is inside it, which is in the oil. This material normally comes from machining or from the elements which are connected to the system. So even the internal components like the power unit, it's the piping and the pump and the screwing. This is all has some certain amount of wear. These particles also enter up in the oil. The second is the dielectric constant. So this is material permeability of material for electric fields. So these are foreign particles in the oil, so not metallic. And these are detected by the electric constant. So also oil oxidation, so oil, for example, is also then able to monitor. The third is the degree of saturation. So here we talk about water amount or water content in the oil. So it's a relative value. So 100% means in this way the oil is saturated. and further water entry is then available as free water. So this is also very important value we monitor. Temperature is also very important, more or less all are important. So oil temperature is monitored over time. So here we see the current temperature, the temperature status. The filling level of the oil is also important, which is necessary because in a system you have always a certain amount of oil which is leaking into area, and so the oil level will never be the same. So we keep this monitored. And as an additional add, of oil filter, which is in the most case part of the hydraulic unit today, is important. The oil filter is normally monitored by the pressure within the filter, so which is detecting that the filling rate of the filter itself. Okay, the next slide, please. So a little bit about the entire, like the problem cause and effect situation. So I told that we talk about here contamination. So we have solid particles. So what is the cause? This is mostly coming from the outside through a venting system. So a lot of components need to be vented. So this is a way that particles can get in. Through seals. So also seals have a certain amount of wear over time. So this then finally leads that particles enter through the seal, and also internal wear of the entire components, like valves, like cylinders, and other components. They all have a certain wear over the time, and so this is also giving some kind of contamination. So the effect is finally increased wear, failure of components, reduction in the system performance, and reduction in the service life. So then we have the other problem, which is the contamination of the liquids. So one is what I said earlier, the water from the air. So we have a certain amount of water coming from the different temperatures, entering into the, or coming from the air, different temperatures entering into water, gets into the system, as well as water through seals in the machining area where we have coolant and other fluids which may enter into the system. So the effect of this contamination is normally corrosion and again reduction on the system performance. Terminal and mechanical load as a third problem. So high temperature from outside or high temperature due to load is then finally affecting again a loss of the function and as well reduction in the system performance. So these are more or less the three main problems we see in our applications and based on our experiences. So next slide, please. Okay, again, the basic measured variables for the assessment of the oil condition. So the temperature, we check the monetary value of oil temperature in the reservoir. We check the level, so this is also the momentary value of oil level in the reservoir. The conductivity, so again, the particles in the oil, the amount of particles. The relative degree of saturation, so the amount of water in the oil, and the electricity, which are other foreign particles which are non-metallic, which are also in the oil. Okay, so the measured variables of the assessment of oil conditions over time. So we also check the trend. So we not just see the status, the current status, but also look to the trend of the system, because in the beginning it's different over time. It is normally increasing, temperature is increasing, the amount of dirt is increasing. So we check the trend of the system, the sensor can check the trend. So the temperature change over time reserves up to the load limit. The change in conductivity over time is the entry of metal dust by a piston rod, for example, the wear of the pumps and valves. The change of the degree of saturation over time is then the water via the cylinder gets in and the water via air, as I said. And the change in the electricity over time is mostly by the entry of liquid or foreign particles filling oil. So you have to keep in mind that the oil coming from a barrel has normally a lot of contamination of particles, which can be metallic or non-metallic. So even when you get the system filled, you already have some certain amount of contamination. You have a certain amount of oil mixing, degradation of additives. So the oil aging is also an effect, and the oxidation by oxygen means acid formation is also oil aging, so-called. Okay, so this is, I think, the last slide we have. So we go back to the power unit. So just again, brief explanation. We have the screen here, and Mr. Karl Hahn. He will show you now the, on one example, the simulation of the system based on, let's say, the conductive foreign particles in oil to see the effect if we change something, which is then the effect, and this effect can be monitored and can lead to another system to do something for the process. Please, Mr. Kanan.
Yes, as Andreas told already, we have here the possibility of simulation. This one is for exhibition, and so we are able to show very easy way what will happen if we change the value of the measurement. For example, the temperature, actually we have a 28 degrees, and if I increase the temperature, you can see the limit for warning is reached. So we have in the maintenance light the yellow lamp, that means attention. Yes, and if the temperature increases further on, then in the end we get a red light of the measurement track. So this is the point where you have to do something. Yes. And this principle is for all measurement valves, which we will have here. And just another example, the water content in the oil. Yes, also first step warning, and second step indication for you have to do something now.
Okay, thank you. So just another few words to the power unit itself and its the capabilities we offer here. So the first is we consider 3 options for such a power unit to be add on with the monitoring system. One is the power unit itself without any control, but with the integrated condition monitoring sensor. So the customer or the potential customer is able then to just get the naked unit and is preparing the control and the final documentation through software by himself. And we offer recommendations about the values, the values which are necessary to set up the system in the beginning, and then to start the monitoring, because all is based on a presetting, let's say. So for this variation or for this variant of offer, we can at least give our recommendations we have from existing applications and experiences. The second variation or variant is to offer the power unit with the panel. So this panel is just a simple hand panel where you can enter, let's say, values, and these values can be monitored and can be read out visually. So you have, let's say, a device could be like a small tablet or a small HMI. So, but this is not really doing a documentation or a reporting. It is just to have a current status of the system, and you can enter your setting, the presetting of values. And the third is the full package, which is the power unit with the sensor and with the full control system and the documentation or reporting system. So then you get the package like the power unit, the sensors, the control box, the cabinet, and a way to display the values and to have the ability to get these values extracted into another system where you can use it for your own application, or we give a certain device or a possibility or solution that we have like a cockpit or something to get this, let's say, visualized in a very simple and easy way. Okay, so these are the three options we consider right now. The system, it's a new system. We have this in our own production and testing area running right now, to have also to see to trends and to get also more experiences with this system in-house, because we have a lot of machining centers and test benches where we have different, let's say, environment and also different influences. So it makes us also, it's a good, let's say good experience we get with our own application. Okay, so some further hints is that this power unit and its sensor is, let's say, it depends where the power unit is placed. So this, the presetting of the 5 values we have explained depends really on the considered environment. So it's totally different if we have a power unit in a foundry running where we have a lot of dirt in the surrounding area, or it's in an area where it's quite clean. Let's say maybe more assembly area or medical field or clean room area. So the influences are quite different, as well as the connected components. Like it's a huge difference of single and double acting components. As I said earlier, single acting components normally do a venting, or there's a venting necessary, and by a venting, normally by experience, a lot of particles can enter the system. So, but all that is something we can also pass on this experiences as recommended values, depending on the different application you may have. Okay, so just keep in mind that we, with our experience, can give here this additional information if it is necessary. Okay, so this is more or less all what we wanted to show in this brief presentation. So first of all, thank you for the attention, and may you have some questions. We would like to answer this within the next minutes.
Yes, we have one question. Can the system be retrofitted to existing power units?
Michael, you want to?
Yes, it is possible. Nearly in every power unit, normally we have to change the inside piping of the power unit, because the measurement sensor must be flown. The oil must be flown through this measurement sensor, and therefore it is possible to make our own circle, yes, for the measurement equipment. And yes, as I said already, normally we have to change the pipe inside the oil tank so that the oil flows through the sensor and back in the tank. In our modular power units, we will create a very simple possibility to fix the measurement into the connection block, for example. So this makes it very easy to equip modular power units in future, additionally with a condition monitoring sensor. Yes, it's possible. Yes.
Okay, we have another question. Which interface does the system have?
The electrical interface of this condition monitoring is an I/O link, and this is, yes, state of the art. And therefore, it should not be a problem to integrate this measurement sensor into an existing PLC of the customer. Yes. Okay.
Okay, no further question?
No further question.
Okay, then we want to close. Maybe just a short hint. We have two further web sessions available. One is tomorrow, which is called Automation mit Hydraulikkomponenten, which is conducted by my colleague Guido Born. And on Friday, so this is by 10 o'clock, 10 o'clock tomorrow. And on Friday by 11:30, we have a web session with the subject Spannelemente mit integrierter Sensorik. Okay, so thank you very much for the attention, and goodbye.